Algebra 2, Module 3, Lesson 31, talking about credit cards and paying back that. Credit cards. So here's Mr. Anderson's soapbox on credit cards. Credit cards are bad, but yet credit cards are good.
Credit or debit?
Credit. Credit cards are bad, especially when you're living outside your means. So I don't have the money for this. I'm going to swap my credit card. Bad idea. I just actually paid off my credit card this morning because every month I use the credit card, and then at the end of the month I pay off the amount on the credit card so it doesn't charge me interest. That's like saying, oh, I don't have money to go to the movies this weekend. I'm going to swap my card for $50. But if you don't pay it off at the end of the month, it's going to cost you, it could be $75 to go to the movies. If that's all you put on there, because they're going to charge you a minimum of $25 in interest. So you always got to pay it off. So that's the bad thing about credit cards. Good thing about credit cards is it's not your money that people steal if they steal your credit card number. Debit card, they're taking your money out of your bank account. Credit card, they're stealing from the credit card company. Okay, so you don't have to worry about getting your money back. The credit card company has to worry about getting their money back. So if you use basically your credit card and pay it off every month, it's a good thing. Don't live outside your means, that type of stuff. Okay, there's my credit card spiel. You're welcome. Let's do some work. It says you have charged $1,500 for the down payment on your car to a credit card. Bad. You should pay the cash for the down payment. You should not be putting it on a credit card, because it charges you 19.99% annual interest. And you plan to pay a fixed amount towards this debit each month until it is paid off. We denote the balance owed after the nth month, or the nth payment, having been made as B sub n. So what is the monthly interest rate? I approximate it to the 5th decimal. Now, how would we figure that out? We would have 0.1999. What? What would we do with that? Divide by 12, and we get 0.01. 1, 2, 3, 4, 5, 6, 6, 6. That is your interest rate each month. That is an astronomical interest rate. That's really big. Okay. Now, we're going to look at the next one. Remember that you can make any size payment towards a credit card debt, as long as it is at least as large as the minimum payment specified by the lender. Your lender calculates the minimum payment as the sum of 1% of the outstanding balance and the total interest that has accrued over the month, or $25, whichever is greater. Okay, so remember that $50 that you spend at the movies, if you don't pay it off, you're going to pay $25 on it. Under these stipulations, what's the minimum payment? Okay, is your monthly payment or at least as large as the minimum payment? So I skipped a problem where it said, all right, you're going to calculate your payments for $50, $100, and $150. So I skipped that. But let's just look and see what is going to be the minimum payment on this $1,500. Now, How would we do that? It's 1% of the outstanding balance. So 0.01 times 1,500. We're going to assume we didn't do anything else. And plus what? The interest rate that's accrued that month. So 0.1666 times 1,500 equals what? So 0.01 times 1,500 is $15. 0.1666. Oh, did I write that wrong? I did write that wrong. That's 0.06. Let's fix that. 0.1666 times 1,500. That is plus $24.99, which is a total of $39.99. So you have to pay $39.99 each month, or for that first month, on that credit card that you spent $1,500 on. So now, remember, this was a down payment for a car. So you have your car payment now, plus your payment to the credit card for the down payment. So really, you've got a big bill for your credit card right now. Okay, or for your car. Now look, we scoot over here, and if we calculate paying $50 a month on this is the $50 a month. Look how much of that goes towards the interest. Remember, our interest for that problem for that first month was $24.99, which means if I pay $50, $24.99 goes towards the interest. That doesn't even knock out $1 of the $1,500. So then the $25.01 goes towards the principal. Okay? And so now you paid $50, but now your statement, your next month bill, is still going to be $1,474.99. Okay? So see how I paid $50, but yet I really only get credit for $25. That's the reason why you don't use credit cards. Okay? But if you use the $100, then you can see there how it's going to, after 6 months, what your payments will be. $50, it's going to be $1,300. And if you use $150, then it's down to $718 after 6 months. All right? Now, how do we come up with that? Look at page 2. How do we come up with this? It says write a recursive formula for the balance of B of n in month n in terms of the balance B sub n minus 1. So recursive means we got to know that previous formula or the previous amount, right? So we would have B sub n is equal to B sub n minus 1 times 1 plus the interest minus your reoccurring payment. So the balance, the previous month, times your interest rate, okay, that's going to give you basically your the amount of your account now. Then we're going to subtract our reoccurring payment, and now that gives us a new balance. Okay? Everybody see that? Take the previous month, do our interest rate, subtract the reoccurring payment, our new balance. Okay? F, write an explicit formula for the balance. Okay? We're leaving the expression 1 plus I in symbolic form. Okay. So, the way this would work is Mm. Okay. So let's do this. We're going to have to say B sub 1 is equal to our original amount. So up here, B of 0 would equal the $1,500, right? Here it's going to be the same thing. So we would have 1 plus I minus R. Okay, that's basically our that is our recursive formula. So now, how would we find B sub 2 would be B2 is equal to B1 times 1 plus I minus R, right? Everybody agree with that? You're going to take your next balance, multiply it, and do it that way. So what you have to do, notice these. B sub 1, B sub 1. I know what B sub 1 equals. So now I'm going to have to plug that into the formula to get my explicit formula. So let's do that. We're going to have B sub 2 is equal to B sub 0 times 1 plus I minus R times 1 plus I minus R. Everybody see that? I need to do this a little bit better here, don't I? Let's do it like that. Okay. All right. Everybody see how I did that? Now let's kind of do explicit formula. Or not explicit. We're getting our explicit, not explicit formula. Sorry. Distribution. Let's distribute this. 1 plus I, the reason why it's in parentheses, because that's a term, right? That's a term. So let's distribute that. What's 1 plus I times 1 plus I? 1 plus I squared, right? Then we can add R times 1 plus I, and then we just have R minus R. Okay? Everybody good with that? So now, what would B sub 3 look like? If we think about it and we do B sub 3, that's going to equal B sub 2 times 1 plus I minus R, right? Well, we know what B sub 2 is now. This is B sub 2. So we would take that, put it into the equation, and work it out. So what happens there? I'm not having, maybe I'll have enough room over here. If we take B sub 3 and we put 1 plus I squared plus R times 1 plus R plus I minus R, that's 1 times 1 plus I minus R. I don't have quite enough room. Let me scoot over here. Let me rewrite that. Together over here times 1 plus I minus R. Okay, so what's going to happen? Well, now we're going to have 1 plus I cubed plus r times 1 plus I squared minus r times 1 plus I minus r. Okay, see how that's going to keep on going? We're just keeping on adding we're adding to our 1 plus I, and we're adding an r to our formula. Oh, wait, did I do? Yeah, a minus r to the formula. Okay, everybody see that? So now that says, G says, rewrite your formula for part F using R to represent the quantity of 1 plus I. All right? So what's that going to look like? Every time you see 1 plus I, we're going to be able to rewrite it. Now, let's rewrite it using our big brain. Okay? Because I don't want to keep on doing 1s and 3s and all that type of stuff. So let's call it B of N. After N payments, right? We want to be done with it. So however many months, basically this is where we're going to start at. B of N is equal to, they call it B of O. Okay? That first month, that first balance, right? Times R to the N power. Because that's 1, look, 1 plus I is R to the N power. Okay? Minus our reoccurring payment. Now, let's do minus R. Okay. How can we do this? Times minus R times. We're going to have to account for that R here. Okay. And then what's happening is we're taking R, which is 1 plus I, and then we're going to do R squared plus R blah, 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 until we get R minus 1. Okay? Everybody see how that's happening here? You can't really see. Let me move over. Let me move over here. See how we have our plus R. Should that be plus R? Why did I write plus R there? All those should be minus R, shouldn't they? Why did I write? I got confused right there. Those should be minus R's. Sorry. Right? Check me. That should be minus R, not plus R. Let me see what it did here. Yeah, that should not be. Sorry, I did that up here too, guys. I got off track. Sometimes I wrote it as a plus, sometimes I wrote it as a minus. I don't know what was going on. Okay, so that is G. Okay, so hopefully you're seeing we've went from our regular, just our boring interest rate times the amount, and turn this into a credit card formula now. So I bet you now, let's see what 3 says. 3 says for H, what can you say about your formula in part G, and what term do we use describing R in this formula? Okay, so going back and looking at it, what is R? What is capital R in this formula? Oh, wait, did they want capital R or little r? Sorry, let me look back. Little r. What is the little r in this formula? It's our interest rate, right? But that's going to refer to, look at where it's placed in this formula. Right here. So that's going to be what's considered. Little r is equal to the common ratio. All right. Now write your formula for part G in summation formula. Okay. So let's see here. Let me go back to it and look here. Well, we're going to start at B of O, right? B of O. So we would say B equals O. Or K equals O. Whatever. Then, remember we have an R to the what? We have a common ratio, right? So we could write that as what? What are we going to be doing to it each time? R to the N minus R. K, right? Or whatever we're going to have here, B. That works. Because remember, R just goes, we're just going to do the common ratio to however many payments we're making. And then where do we stop? Well, at some point where we have N minus 1, wherever we end up at as far as we pay off our payment, right? Whether we're spending $50 a month on the payment or $150, it's going to change because we don't know where we're actually stopping at. Okay? So that's what it's going to look like. All right? Apply the appropriate formula for lesson 29 to rewrite your formula for part G. Okay, so what that means is, remember we done capital R as 1 minus R to the N over 1 minus R. That's what we did for lesson 29. So now we're basically going to replace R here, capital R, where we did the summation of those numbers, right? That's what we're replacing here with our previous formula. So when we do that, we would say, B of N is equal to B of O times R of N minus R, so we would normally say 1 plus R, blah, 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 R. So that's our formula now, okay? But we're going to replace this and say B of N is equal to, if I just say born, are y'all good with that? Instead of me having to say all those letters and numbers. Times 1 minus Rn over 1 minus R, that way. So we're just replacing it with that. Now, what is significant about that? Well, I'm glad you asked. Because what we're going to do, I think, did I move this to page 3? Uh-oh. Okay, go ahead and go to page 4. I know there's a K on there, but I moved it to page 4 because it's going to be way too long. Okay, so here, what are we finding here? We're finding the month when your balance is paid off. And remember, that's all going to depend on how much you're using at the end of the month, how much you're paying. If I'm paying $50, I'm going to pay it off. It's going to take a lot more months than if I'm paying $150. That just makes sense, right? So let's find out the formula for how we're going to do it. Because we don't want to just start plugging in a number and have to do it. So we're going to take our previous formula that we just figured out, our born formula, minus R times 1 minus R to the N over 1 minus R. Okay? Now, what do we want that to equal? We're taking our balance, we're taking our interest rate, we're taking the number of months, and then we're subtracting our reoccurring payment, which is also going to be the sum of those, right? So what do we want all that to equal? What's the whole point of paying on your credit card? We want it to equal what? Guys, what do you want your credit card balance to equal? 0. So we're going to set it equal to 0. We want it paid off. So we want it to be 0. How are we going to do that? How would you solve this? Once again, this is just manipulating these formulas. What's the first thing we're going to do? Well, if you divide by 0, you're going to get 0. So we're not going to do that. What can we do? Let's move it to the other side. So we're going to have B born is equal to now a positive R1 minus R over N over 1 minus R. Everybody see that? Just moved it over there. It was subtraction, so we're going to move it to the right. Now, what are we getting? First off, what are we solving for? We want our number to be 0, but what are we actually going to be solving for? Notice, find the month. So what part of our formula is the month? N. So we're trying to get N to equal something, which, doggone it, it's an exponent. That means we're going to have to do what? We're going to have to log it at some point, right? That's the whole point of these last however many weeks or months it's been, using these log functions. All right? Now what are we going to do? What would we do? I'm going to get rid of this fraction over here by multiplying by 1 minus R. Okay? That cancels here. So I'm left with 1 minus R times is equal to R times 1 minus R to the N. Now what? Anybody got a suggestion? Let's work on the right side over here, and let's go with distributive property. We're going to let it be with R minus R little r n. Okay. And 1 minus r times this. Okay. Now what can we do? Because the whole thing we're going to have to try and get our n's on one side, right? And then we'll have to log it. So how do we want to get n by itself here? Let's move. Go ahead and get our n's together here. Let's go ahead and say 1 minus r times b o r n plus r little r to the n equals r. So I'm just moving that to the other side. So now I've got n's together, but I don't have n's by themselves. What do we want to do here? I can factor out r to the n, right? I can essentially say, I can do this. R to the n times that's going to leave me with BO times 1 minus R plus capital R, close parentheses, equals R. Now I can just divide by that. So let's move over here and say R of n times BO 1 minus R plus R equals R. And we want to divide by So I got to put my parentheses back. We're going to have to divide by this whole thing. B of O times 1 minus R plus R. If you do it to one side, you got to do it to the other, which is going to leave us with R over B of O 1 minus R plus R. Now we can log it, right? Now we'll log both sides. So that would give us n log R is equal to, yep, perfect. That's what we want to do. Log of R over BO 1 minus R plus R. Now we can divide by log of R, divide by log of R, and we have n equals log of R over BO 1 minus R plus R over log of R. There you go. So now, if I want to know how many months it's going to take to pay off my credit card, now I have it in the form where I can plug in my recurring payment, I can plug in my rate, I can plug in the initial balance, and I'm done. I now have my answer if I can do that in a calculator. Right? So now let me list that right quick so we know what we're talking about here. N is equal to the months to pay off. Okay? R is the R is the reoccurring payment. Okay. Now, listen, this only works if you're paying the same amount each time. Right? So if I pay $50 this month and $75 the next month, it's not going to work out. So it has to be the same equal payment every month. And we know R is the equal to the, what do we call that? What did we call that earlier? The interest rate, I guess. Okay, and that's all of them. All right, so let's try one. If we do log of 50 over $1,500 times 1 minus, I don't remember what our R was. What was our R? R was 0.1666, I believe. Okay. And what else? Plus 50. All over the log of 0.1666. All right. If you can't plug that into a calculator and get the correct answer, you're really going to struggle. Because we just now worked out the formula, so all we have to do is plug it into the calculator. So you're going to have to be able to manipulate your calculator now to give you the answer that you want. I got in mind when I worked it out a long time ago, I got 41. I got N equaled 41.925. So we would have to say that would equal 42 months. Okay. Now, next page. You wouldn't want to be able to do that for 100 and 150. Okay. Now the next page says nothing. Y'all got anything on that page? I've got an error loading. Oh, it's going crazy. Like, no joke. And it just shut down. Give me a second. Restore. Stop. Now let's go back. Give me just a second. Okay, there it goes. Now refresh. Okay, calculate the total amount paid over the life of the debt. How much was paid solely to interest? Okay, so let's just take the $50 into account here. Okay, we're going to pay $50 a month, right? What formula are we going to use now? How are we going to find out our formula for how much money it's going to be over the course of the lifetime of the loan? We're going to use what? So what is the AP formula? Wait, say that again? Capital R times what? Okay. Mm, first of all, okay, I know because that's the annuity prince. You're looking at the annuity present. Okay, let's do. We've already calculated that it would take $50 to pay it off, right? Or we're going to use $50 each month to pay it off. Now, we don't make a payment that first month, like when we start putting money on there, right? So we're going to say $41. Well, not necessarily the first month. You're going to make reoccurring payments for 41 months because that last month is going to be a little off. It's not going to be exactly $50, right? So for 41 months, because we said it's going to take 42 to pay it off. For 41 months, we're going to pay $50. So what is that? 2,050? Okay. Now we're going to have that type of payment for that month, for those months, plus our formula here. Over 1 minus R. Okay. So what is N? We can plug that in as 40 We'll plug 41 or 42 in there. Let me check that because I want to check, make sure that's correct. Is anybody looking at it right now? That can tell me? Anybody looking at the answer sheet? Speak up, save us some time. No. Okay. I should have already had it brought up. All right. Is that 41 or 42? Or did they? That will be 41 as well. Okay. So that'll be 41 R to the 41 minus the 50 times 1 minus R to the 41 over 1 minus R. Now, I don't remember what our 1 minus R was. Does anybody, it was 0.1666 or 0.01666, right? Let's do 0.01666 times 1500. R is 0.01666. All right, so R equals 0.01666, right? So if you plug R into all of those positions, let me just say R here into this 1500 times that, you should get plus actually it ended up being minus it'd be something like that. And that equals all right, guys.